Dear students, warm welcome to all for this session, Reflection of Light at Curved Surfaces, part 3, Ray Diagrams for the Concave Mirror. By drawing ray diagrams, we can find the nature of the image formed when the object is kept at different places. To draw the ray diagrams, already we have discussed in previous session that we have to follow some rules. When a ray is parallel to the principal axis, after reflection it passes through focus. Second rule states that when a ray is passing through focus point, then after reflection it passes parallel to it. Third one, if a ray is passing through center of curvature of the mirror, after reflection also it passes through center of curvature. And a ray which is incident exactly at pole of the mirror, after reflection it reflects such a way that that angle made by the incident ray with the principal axis is equal to the angle made by this reflected ray with the principal axis. So we have to use any two rules to draw the ray diagrams for the concave mirror. Let us see. First, when the object is at infinite distance, we know that when the object is at infinity distance means from where the parallel beam of rays produces, that point is said to be infinity point. So here, this is the principal axis. So a ray is parallel to the principal axis incident on the mirror. So it reflects such a way that it passes through focus. So this is another ray. After reflection it passing through the focus point. So here where these two reflected rays intersects, there we are going to get the image. Means in this case we are getting image at focus point, and it is real and inverted, a point size image we are getting at focus point. Now let us see when the object is beyond center of curvature. So this is the mirror. So let us take a lighted candle beyond the center of curvature. So first ray we are taking parallel to the principal axis. So after incident on the mirror it reflect such a way that showing it is passing through focus. And the ray we are taking through the focus. So after reflection it passes parallel to the principal axis. So these two reflected rays are intersected where that we are getting the image invertedly. So here real, inverted and diminished image formed between center of curvature and the focus. Now let us move the object towards the mirror. Now we are keeping the object at center of curvature. When the object is at center of curvature, let us see where do you get the image. So this is the principal axis. So we are keeping the object at center of curvature. Let us take one ray parallel to the principal axis. So here is after that it is reflecting to pass focus. Another ray we are taking through focus point, so that it reflects such a way that it is parallel to the principal axis. So here we are getting the image at center of curvature. Means the same size image we are getting, that center of curvature, it is inverted. So real, inverted and the same size image formed at center of curvature. So here you can able to see the ray diagram also. See here is this is the object. So parallel ray, after incident passing through focus. This is passing through focus, after incident it is reflected here. So the image we are getting at center of curvature, same size image and inverted real image. Next, let us see when the object is at focus and center of curvature. between focus and center of curvature. So this is the concave mirror. So we are keeping this is the principal axis, we are keeping the object between focus and center of curvature. So first ray we are taking parallel to the principal axis. So after reflection we know very well that it passes through focus. Another ray we are taking through focus point. So after reflection it passes parallel to the principal axis. So here both the reflected rays are intersecting beyond center of curvature, where you will get the image. So here if you see the image here, image we got beyond the center of curvature, it is inverted, real, and comparing with the object it is enlarged. So here we are getting real, inverted and enlarged image formed beyond center of curvature. Now you can see ray diagram here also. Now we are moving object towards the mirror. Now let us keep the object at focus point. So here we kept the object at focus point. So first of all take the parallel ray to the principal axis. As you know that after reflection it passes through focus. But here another ray we can't able to take the through focus because object only at focus point. That's why let us introduce another rule. So the third rule is here, a ray which is passing through center of curvature, after reflection it passes through the center of curvature only. See, so here like this. So it is passing through center of curvature, after reflection also passes through center of curvature. So if you observe these two rays, reflected rays, they are going to intersect somewhere, means some long distance, that we consider it as for infinite distance. Means here real, inverted and highly enlarged image formed at infinity distance when the object is at focus point. Let us discuss about that one more. Now we are keeping the object between focus and pole. Let us see what happens. So this is the mirror. So it is principal axis. We are keeping the object between focus and pole. So this is parallel ray. One ray we are taking parallel to the principal axis, so it is reflects through the focus, and another one as usual center of curvature. We know that well, while a ray passing through center of curvature, after reflection also it passes through the same. So here if you observe these two rays, they are diverging. These two rays are reflected rays are diverging. So that means we won't get a real image here. So to identify the position of the image, let us expand this focus reflected rays both behind the mirror. So here both these reflected rays are intersecting behind the mirror, where you will get the image. See here what kind of image it is. Comparing with the object, it is enlarged image. So here this type of images are said to be virtual images. These virtual images we can't catch on the screen. So here when the object is at focus, we got enlarged image, but it is real. When the object is between focus and pole, here also we are getting enlarged image, but it is virtual and erect. So virtual, erect and enlarged image formed behind the mirror. If you compare these two characteristics, in both the cases we are getting enlarged images, but when the object is at focus, also we are getting enlarged, highly enlarged image. Here also we are getting enlarged image. When the object is between F and C, we got enlarged image. So here the difference between those two images are, when the object is between C and F, we got the image beyond center of curvature, it is enlarged, but it is a real image. And when the object is at between F and P, we are here also getting enlarged image, but it is erect and virtual image. Now let us simplify that what we have observed in table. So here the characteristics of image formed by the concave mirror. Let us tabulate this all the information. First, position of the object, position of the image, characteristics of the image. When the object is at infinity, so we got the image at focus, it is point size image. When the object is beyond center of curvature, we got the image between focus and center of curvature, it is diminished, inverted and real. When the object is on the center of curvature, we got the image also on the center of curvature only. It's a size, we got the same size, inverted and real. When the object is between focus and center of curvature, we got the image beyond C and it is enlarged, inverted and real. When the object is on focus point, image we get at infinity distance, it is highly enlarged, inverted and real. When the object is between pole and focus, we got the image behind the mirror and it is enlarged, erect and virtual image. So in this way, while keeping the object at different position, we will get the image at different places and the characteristics of image also be changes. It is depends upon the position of the object. So in SSC examination, they may give this type of table to ask the questions related to the table. So that's why you have to remember the position of the images and position of the objects and their characteristics. It is very important. I hope you have all understood how to draw the ray diagrams and how to get the characteristics of the image. Thank you. Have a nice day.